Okay, problem 14 is a typical IB problem. It looks like and is an exponential functions problem, and then they kind of throw a little twist, and we're going to be solving a linear system of equations in just a second. So let me show you how this is going to work out. So I've got this equation, and don't let that equation freak you out at all. It says the number of cells is equal to, and think of this as the number of cells is equal to a times b to the x, and then they're just adding some constant onto the end of it. And we know and we're comfortable with how these exponential functions work. They tell me that the number of cells in a culture at 12 o'clock is 47. I'm going to use 12 o'clock as my time zero. So this is when time is equal to 0. And then at 16 o'clock, that's world, universal world, military, whatever the heck time that is. But what's time? It's 4 hours later. So my time is going to be equal to 4. That's kind of a key piece to getting this problem to be easy. And they want me to write down two equations in P and Q. So here's what I'm going to say. I'm going to say at time 0, the number of cells I have, 47, is equal to P, I don't know what that is, times 2 to the power of 0.5 times 0 plus Q. So think about this. Right here, let me just put a little blue line under there. The exponent becomes 0.5 times 0, so that's 2 to the 0, which you know is 1. So then the problem becomes 47 is equal to, well, P times 1 is just P plus Q. Isn't that slick? All right, and now for a second equation, I'm going to say, well, 4 hours later, the number of pieces of, what are they? Pieces of cells in my little petri dish is 53. And that's equal to P times 2 to the power of, again, 0.5 times 4. That was 4 hours later, so my time was 4 plus Q. Don't know what Q is. But I can simplify this. If I have 0.5 or half of 4, that gives me 2. And 2 squared is 4. So 53 is equal to 4P plus Q. Well, this thing becomes pretty easy to solve right here. Let's just solve for Q. 47 minus P is equal to Q. I'm going to substitute into the other equation. 53 is equal to 4P plus 47 minus P. So subtract 47 from each side. Subtract 47. And 53 minus 47 is 6. 6 is equal to 4P minus P, 3P. So P is equal to 2. And now I need to figure out what Q is. I can substitute into either of my equations, but I'll just go right back here since I'm already solved for Q. So 47 minus 2, because that's what P is equal to Q. So Q must be equal to 45. All right, that's the first part of the problem. That's pretty, well, once we figure out a way to set up time as 0 and 4, that's what makes that problem really easy. So we wrote down two equations, and down on your little answer sheet, make sure that the two equations that you write down are this one, there's equation 1, and this one, there's equation 2. And we found the values of P was equal to 2 and Q was equal to 45. And now they say to find the number of cells in the culture at 2200 hours. So that's 10 hours after our 12 o'clock. What we need to do is we need to write ourselves an equation with the P and the Q in it. So I'm going to say the number of cells is equal to, we said P was 2, and our formula is 2 to the power of 1/2 T, 0.5 T, I guess I'll write that like this, plus Q, and Q we decided was 45. So if T is 10, since 2200 is 10 hours after 12 o'clock, C is equal to 2 times 2 to the power of, well, half of 10 is 5, plus 45, and I don't even need my calculator for the rest of this. C is equal to 2 times 2 to the 5th is 32. Please do those in the right order. Plus 45. Do not multiply the 2 times 2. So I've got 2 times 32. That would be 64 plus 45. And that's going to give me 109 cells at 2200 hours.